All right, getting started on problems based on homework number 8 now. Let's go ahead and take a look at number 1. And it tells us if f of x is equal to 2 times x to the negative 3/5 plus 5 times x to the 5/2, then our derivative of f of x should be written in this form, and we have to figure out what each of those letters ends up being in this particular instance. So let's go ahead and take the derivative of f of x, and in this one, we see pretty clearly right away that the only thing that's really happening is we've got some coefficients, which don't mean much to us, and we've got some exponents to work with. So it looks like we're just going to be using the power rule. So we also want to take into account the sum rule. I see that since there's addition here, my derivative is just going to be the derivative of this plus the derivative of this, right? Doesn't change much for us. So the derivative of 2 times x to the negative 3/5. Well, let's figure out, we've got x to the negative 3/5. That would turn into, if we take the derivative, remember we put that down in front as a coefficient, so it's going to be negative 3/5 times x to the, whatever this is, minus 1. Obviously, negative 3/5 minus 1 is the same as minus 5/5, right? Because that's 1, which gets us a negative 8/5. So that's going to be our new exponent. And now, since we saw that there's a coefficient of 2 right in front, we're just going to multiply that back on. So because there's that 2, I'm going to do 2 times that. So 2 times negative 3/5 is going to be negative 6/5. Then it's still times x to our negative 8/5. So we've got our first term already. And then it's just going to be plus whatever this derivative is. So again, we've just got that 5 times x to the 5/2. Let's figure out x to the 5/2. The derivative of that, again, is power rule. So we take this, take our exponent, we put that in front. That's our new coefficient. And now we subtract 1 from our exponent. In this case, 1 would be the same as 2 over 2. So it's 5/2 minus 2 over 2, which is 3/2. So that's our new exponent. So that's the derivative of that bit. And we notice here that there's a 5 in front. So it's this times 5. So 5 times 5/2 is going to be 25/2 times x to the 3/2. And there we go. That's our derivative of f of x, because there's no more terms. There's no other rules that we have to apply there. All that was our power rule. So there's our derivative. Oops. There's that derivative. So let's see. It looks like it's already written in terms like this. So a is our first coefficient. So a is going to be a negative 6/5 here. B is that first exponent. So in this case, it happens to be negative 8/5. C is going to be our second coefficient, which is going to be 25/2. You could also write that as maybe 12.5. We could always put those as a mixed number, whatever works. And then D is going to be our next exponent there, which is 3/2. Or you could write it as, obviously that's the same as 1.5 or 1.5, however is easiest for you to write that. Go ahead and do that. I personally think it's a lot easier to work with fractions if I'm not using a calculator. Just because we can get some funky fractions sometimes, and those get especially weird as decimals. For this next one, we've got h of s equals, oops, that should not be a t. That should be an s. So it's 3 times cosine of s to the 4th. So there's 2 things I notice here. First, well, 3 things actually. So first, we've got a coefficient, so we'll want to put that in front. And then we've got a trig function. And inside, we have something else that we could take a derivative of because there's that exponent. So I know for this one, I'm going to use chain rule. So if I want to find the derivative of this, remember it's going to be a coefficient times the derivative of whatever that inside is. So I can rewrite that as 3 times the derivative of cosine of s to the fourth. And now I just need to figure out what this derivative is. So if we use our chain rule, I know that chain rule tells us that the derivative of this is going to be the derivative of the outside times the derivative of our inside, right? Because it's our inside-outside rule. So, and just, this one's really easy because there's only one inside, one outside. But for consistency's sake, I'm going to write this out the way that I normally write out chain rule. So I'm going to give these variables. So I've got u, I'm just making up variables, right? U, I'm going to say equals cosine of v, okay? And in this case, we see v is very clearly s to the fourth. Well, because of chain rule, I know that the derivative of u is going to be the derivative of my outside, which I know derivative of cosine is negative sine. That's going to be that same inside, times the derivative of my inside. So I'm going to make a note of that. Now, take the derivative of our inside, which is s to the fourth, and we use our power rule there. So 4 is our exponent, becomes our coefficient, and we subtract 1 from that exponent, which tells us that our u prime equals negative sine of s to the fourth times 4s cubed. And obviously I could rewrite that. I could move that or this whole term in front, and I think I just might. So we've got our negative, so it's a negative 4s cubed, and I can do this because we're multiplying, right? And that is communicative. And there we go. So then that's our derivative right up there. And remember, we've got that 3 on the outside, so we have to remember to multiply all of this by 3. So it's going to be 3 times negative 4s cubed times sine of s to the fourth, or just negative 12s cubed sine of s to the fourth. There is our derivative, and I'm going to go ahead and write that right over here. Ta-da! Now, number 3 is an interesting one. We have our function L, so it's a cursive L, equals 12 times cosecant of c minus 1 over c cubed. And now we want to figure out what the derivative of L with respect to c is going to be. So, looks like we have to use our quotient rule here. Remember, our quotient rule, as I like to remember, is low d high minus high d low over low low, which remember that's the lower term, so the c cubed, times the derivative of our higher term, which is this whole thing, minus our higher term, times the derivative of our lower term, all over whatever our lower term is times itself, so squared. Which in this case, we've got our lower term is c cubed times the derivative of our higher term. So we need to figure out what the derivative of this is. Well, I know the derivative of a constant is 0, so I know I can ignore that 1. I just have to worry about this right here. Remember that this is our coefficient in that part, so I know it's going to be 12 times whatever the derivative of cosecant of c is. And if we remember our trig derivatives, I know that the derivative of cosecant should be negative cosecant times cotangent. Okay, so it's going to be 12 times, oh, we'll put that negative in front, so negative 12 times cosecant of c times cotangent of c. So I can put that right in front, and actually I'm going to put the negative 12 in front right there, just because it's personally easier to read. So I just put that in front. And I can do this, remember, because this is all multiplication happening right here. And now our next part, so we just did the bottom term, which was that c cubed, times the derivative of our higher term, which was that right there. So I've got all that multiplied. Now minus our higher term, just as it is. So that's 12 cosecant of c minus 1 times the derivative of our lower term. And this is a nice easy one for us. So the derivative of c cubed, we use that power rule. It's going to be 3c squared. And then all over, let's write that out, c cubed times c cubed, or I could rewrite that as c cubed squared, which simplifies to c to the 6th. Okay, so let's see. I'm actually gonna I'm gonna distribute some of this just to take a look at it a little bit closer. Let's see. Got cosecant c, cotangent of c, minus, I'm going to distribute that 3c squared, so it's going to be 36c squared times cosecant of c. Oops, ran out of space. And then minus 3c squared all over c to the 6th. And for right now, I'm just going to leave it like that. And we see that it's already c to the 6th. That's what we found. So that's what they want for our first answer. It's just all of this over c to the 6th. I'm going to go ahead and write that. I know it's kind of a lot. There's a lot happening here. Oops. Looks like we run over it a little bit. What did I say that was? That was going to be... Oopsie daisy. Forgot to distribute that negative, so that's going to turn into a plus right there, because that minus a negative 1 times that. Okay. So let's see, negative 6, oops, c squared times cosecant of c plus 3c squared. Okay. Awesome. And now they want us to further simplify this, and I know that looks really intimidating, but what we want to figure out is what term do I see in every part of my puzzle, right? So I see that I've got a c to the power of something in every piece of addition there, so I'm going to factor that out. I'm going to factor out, and I can actually factor out 3 as well, but I'm just going to factor out the c right now. So it's going to be, let's see, we can only factor out up to a c squared because that's our lowest one. So I'm going to do c squared times, and now inside I see I've got that negative 12, and that'll still be times a c times this first term here. And then we also factor out of this term right here, so it's going to be minus 36, and we've just pulled that c squared out, so it's just 36 cosecant c plus 3 times c squared, and since we factored or pulling that out, it's just going to be plus 3 all over c to the 6th. That makes it pretty easy because we're multiplying. That means that I can divide these right here, which means I can cancel out the c squared, because c squared divided by c to the 6th is just going to be 1 over c to the 4th, right? Or c to the negative 4th, but we're going to keep it like this. Oops. Which tells me that cancels out. So I've just got all this rest of the bit right up here, which I'll rewrite. And we don't need it in parentheses anymore because we're not multiplying by anything because we canceled out that c squared. It's all going to be over c to the 4th. And that should be the simplified answer they want. We could technically like pull out that 3 right there, but it doesn't help us at all. So just gonna rewrite what we just got over here and try to keep it on there. Okay, and that is our answer. Now looks like we're going to get a lot happening once again. So we're given that this function f of x is equal to 2 times tangent of 5x cubed minus 1. And remember, this right here is the same thing as if I did this. That is the exact same as writing that 3 right up there. So it's whatever tangent of 5x is cubed. Okay, just in case that was unclear for anybody. So we want to take the derivative of this, and it's eventually, hopefully, going to make its way into terms like this. And then we just need to figure out what each of those letters represents. So I can see already that I'm going to need to use chain rule, right? So once again, I'm going to use my u's and my v's and maybe a couple other variables. So I know, let's say our first outside is going to be this tangent cubed, right? So I know that my f prime is going to be whatever 2 times u is minus 1, and I'll use u to represent that tangent cubed of another inside variable, right? Actually, sorry, I don't want to use f prime there. I want to use a different variable. I'm going to switch these around. So u and v, I'll put a line through. Nope, that's a whole different thing. I'll put that, and I'll use, let's say, c for our 5x. And then c equals 5x, and I see I've got no other insides anywhere. So I know that u prime, or the derivative of u, is going to be whatever the derivative of this is times the derivative of this. So, and the derivative of 2v is just 2. I know that the derivative of a constant, -1, is 0, so I don't have to write that. And I know that this is going to be times my inside, right? Derivative of my outside times my inside. Or rather, my outside times my inside, and then this is a separate little piece. So then we want to take the derivative of the first inside, and since this also has an inside, we're going to use chain rule again. So derivative, sorry. Oh, and it looks like I made a mistake. It might be clearer for me to restart, so I'm going to do that. I'm so sorry. Let's start over. So again, f of x equals this. I'll say that u equals 2 times v cubed. There we go, v cubed minus 1. Now our v can equal tangent of 5x, because remember, this is the same as this, and we know that it's going to be that inside of there. Oh, and I don't want to use the 5x actually, because I want to use another variable, because we still have to go chain rule again. So you see how I've kind of broken this up into a bunch of insides and outsides. So then our derivative of u is going to be the derivative of this times, or minus the derivative of that. So the derivative of 2 times v cubed. Pull that 3 in front. 2 times 3 is 6. Power rule, so we subtract 1. And then the derivative of a constant is 0. And then it's going to be that times whatever the derivative of our inside is. Our inside is tangent of c. So let's figure out that derivative. Well, we know the derivative of tangent is secant squared. So it's going to be secant squared of c times, and because this is chain rule, times the derivative of our inside, and our inside is c. So then the derivative of that is, again, we apply our power rule, and that's just going to be 5. Now I can go back and plug these in. So the derivative of v is secant squared of c, which is 5x, times the derivative of c, which is just 5. And then we plug that into our derivative of u, which was just 6 times v squared, so it's going to be 6 tangent squared of c, which is 5x, all times the derivative of v, which I see has a 5 times secant squared of 5x. And we'll notice that they've got their secant before their tangent, and we can just switch that around because we're multiplying. So I'm going to see, I see I've got 2 coefficients that I'm multiplying together. So let's just simplify that. So it's a 6 times a 5 is 30. And then I'm going to flip my tangent and my secant around just so it's in the same terms. So secant squared of 5x times tangent squared of 5x. And that is our derivative. Let's come back now. And I'm actually, let's see. Let me select this. We'll bring it back down to where we can see it. Oops. Okay. And so we see a times our secant. That's going to be that 30 there. So a equals 30. Got secant to the power of b, which is 2. Inside my c is 5 times tangent to the power of d, which is also 2. And my f is also 5. All right, now for a problem kind of just like that one, and just as messy and tedious. We've got f of x equals secant cubed of 6x squared plus 2. So again, I'm going to use u for my first outside, and I see that my first outside is something cubed. So I'm going to say v cubed plus 2. That's my u, right? And then we see our v is very clearly the secant of 6x squared, but I know that this is another inside, so I'm going to separate that out. That's my c. And then c, like I just said, is 6x squared. And then once again, just figure out our derivative of u. It's going to be the derivative of this, so it's going to be 3v squared because of power rule. And then the derivative of constant is 0. And then multiply the whole thing by whatever the derivative of this inside bit is. Then we figure out what that is. So the derivative of secant is going to be secant times tangent. And again, since this is chain rule, we have to multiply all of that by the derivative of our inside, which is c. And then the derivative of c, let's see, we apply our power rule. That's going to be 2 times the 6 is 12, c to the first, or just 12c. And then if I plug that back in, the derivative of v is secant of 6x squared times tangent of 6x squared times 12x. Sorry, I didn't mean to write a c here. And then I take this and I plug it in for my v prime. So the derivative of u is 3 secant of 6x squared squared, so it's secant squared 6x squared, times, now secant of 6x squared times tangent of 6x squared times 12x. And once again, I'm going to simplify this, and I can pull out these parentheses. I didn't actually need them, right, because we're working with our trig function, so that's pretty clearly what it is. So I know that a secant squared times a secant, and I see I've got the same inside, so I can combine them. Those are like terms. this right here is going to turn into secant cubed 6x squared. It feels like we're kind of right back where we started with that, but that's okay. I see I've got another coefficient. I'm probably going to move that x in front, actually. So I've got 12x times 3. I'm going to move that in front, so 12 times 3 is 36x. So I've done with that, and then it's all just multiplied by this right here. And let's see, is that in the form we want it to be in? I'll rewrite it down here actually, so that we can see it clearly alongside the question. Okay, yep, that's it. And so we've got an ax times secant to the power of b of some inside times tangent to the power of e of some inside. Yep, that is the exact way we've got it written here. So we see ax is 36x, so a is 36. Secant is to the power of 3. Our inside, that c is a 6, that d is a 2. Our e, this is just tangent, so it's tangent to the first, right? Not to the 0th, because that would make it 0, or sorry, it would make it 1. Then f, c is a 6, and g is a 2. Moving on to number 6. Once again, more chain rule. This homework looks like it's pretty entirely on chain rule, which it's annoying and tedious, but it's really good to have chain rule down, get lots of practice with it, because if you aren't super familiar with it, it can be really hard. So f of x equals this, and we want to get it in terms like this, but let's not worry about that right now. We're just going to take the derivative. So once again, I see my first outside is whatever's inside here to the 7th. So I'm going to say u equals v to the 7th. And then inside there, I see that v equals, well, I've got two terms. So I've got x cubed. That's pretty easy to take the derivative of. No inside, so I'm going to write that. Just x cubed plus, this looks like another inside. So I'll call this c to the 4th. Okay, and then c is just 2x plus 3 because there's no more insides. And then, per usual, derivative of u is going to be 7 v to the 6th by our power rule times the derivative of v. Then the derivative of v, well, we've got our sum rule here. So first we take that right there, so 3x squared plus 4c to the 3rd. And since this has an inside, took the derivative of our outside, and then multiply that by the derivative of the inside. Notice we only multiply that bit there and not this whole bit, because this is just the outside there. So then I'm going to find our derivative of c, and that's just going to be 2, right? So we plug that back in. So that's going to be 3x squared plus 4 times 2x plus 3 to the 3rd times 2, and I can combine those coefficients, so I'm going to rewrite that as 3x squared plus 8, because that's 4 times 2, oops, to the 3rd. All right, this is my derivative of phi, and I plug it all back up there, so 7 cubed plus our c is this, plus 3 to the 4th, all to the 6th, then times 3x squared plus 8 times 2x plus 3 to the 3rd. All right, and again, I'm just going to pull that down forward for us because that is our final derivative. And let's see if we've got it in the right terms. Let's see, we've got an a on our outside, that's right. We've got an x cubed plus this to the power 4 to the power of b, good. All times, yep, looks like it's in the right form. So we see our a is 7. We've got all of this, our b is 6, c is 3, D is 2, F is 8, and G is 3. All right, we're making some headway. Let's see, we've got just a few more questions left. A little over halfway now. And then once again, chain rule. So they tell us h of x equals this right here. So we want to figure out what the derivative of h of x is, also read as h prime of x. So let's see, I've got my inside and outside. So I'm going to say u equals v, my inside, to the 1/2 power. Or I could also write that as the square root of v, but it's honestly easier to work with as a power. So then my v is that inside. So it's going to be 2 minus 3 times, oh, I see I've got another exponent. So that's my inside and that's my outside. So we'll say c to the 5th. And we'll say c is just cosine of x. Now, just like we did with the last one, figure out that the derivative of u is going to be this right here. Take our power rule, subtract 1, and then multiply that by our derivative of the inside. Take the derivative of that inside, it's going to be 2 minus power rule, 5 times 3 is 15, c to the 4th, and then of course times the derivative of our inside, and our inside derivative is negative sine of x, because the derivative of cosine of x is negative sine of x. Plug that all back in, we get, oops, gotta plug it in here first, so 2 minus 15 cosine to the 4th of x times a negative sine of x, and I'm going to combine those actually, so 2, negative, negative, so it's cancel out, so plus 15 cosine of the 4th of x sine of x. Okay, I'm just going to write it like that. Remember, this is all multiplying there. And now I plug that in for my derivative of v, so I've got 1/2. My original thing is 2 minus 3 cosine of the 5th of x, all to the negative 1/2, which just means that it would be like that, right? And then times our derivative of our inside, so it's 2 plus 15 cosine 4th of x sine of x, and we can just leave it like that. So actually, for effort's sake, I'm just gonna, I'm just gonna pull this right on over. Let's highlight it again. Oh no, I lost the 1 in my 1/2. Oh no, now I've lost a parenthesis. Maybe this isn't working as well as I was hoping. There we go. I know it's kind of in there, but this is our answer. All right, for this next one, we do have to use chain rule again, but we also have to use product rule, right? Because we see we've got this product and both have a t in them, so it's not merely a coefficient. So if we have g of t, oh my goodness, that should be a g. So if we have g of t equals e to the power of 4t times cosine of 5t, we want to figure out what the derivative of this is. Well, we remember with our product rule that the derivative of a product, so say the derivative of u times v is like so. So it's our first term times the derivative of our second term plus the derivative of our first term times our second term. And I always just write this so I don't forget. And so we'll first see we've got our first term, so it's going to be e to the 4t times the derivative of cosine to the 5t, or cosine of 5t. And this is where our chain rule comes in, right there, right? Because I've got an inside. So u equals cosine of v, v equals 5t, u prime is going to equal the derivative of that, which is going to be negative sine of v times the derivative of our inside, which is just 5, which makes that, it's going to be negative sine of 5t times 5, and I'll actually put that 5 in front with the negative, or, yeah, so times negative 5 sine of 5t. All right, I'm going to erase this bit here for space's sake. All right, so we've got our first bit. We did the first term times the derivative of the second term. Now we need to add that to the derivative of our first term times our second term. Well, the derivative of our first term, we know that the derivative of e to the x is just e to the x. And we know that a couple ways. A, we might just have it memorized, but we also know that the derivative of any number a to the x is going to be a to the x times the natural log of a, and if in this case it's e to the x, it's going to be e to the x times natural log of e, which is just e to the x times 1, or just e to the x, right? So now the derivative of e to the x is itself, but this isn't just e to the x or e to the t, it's e to the 4t, which means that this is our inside here. So our outside in this case is u equals e to the v, and v equals 4t. So the derivative of our outside is going to be e to the v times the derivative of our inside, which makes this 4, because that's our derivative there, times e to the 4t is the derivative of e to the 4t. So let's put that there. So 4 times e to the 4t, and then times our second term, which is cosine of 5t. Now, the tricky bit. This is our derivative. That should not be an eraser. Why does it always erase the things I don't want it to? Goodness. That was unpleasant. So this is our derivative, but that's not in terms of this yet, is it? So I see that we need to factor out an e to the something power, and I see that I've got an e to the 4t in both of my terms. So we're just going to factor that out. So e to the 4t times, right here, it's going to be negative 5 sine of 5t plus, and it's going to be 4 cosine of 5t. And now it is in those terms. So we see that e to the a t, a is 4, b is going to be that negative 5, and c is just 4. All right. Now we're going to be doing chain rule again. We're also going to be needing to know our derivatives of our natural logs. And so there's two things I want to point out. So we might have memorized that the derivative of our natural log is just 1 over x, which is certainly helpful. But if we ever forget that, just try to remember the derivative of our logs, because it's more helpful to know that than to just know our natural log. But if I have a log with a base of b, the derivative of that will be 1 over the natural log of b times x. And that works out if I've got a natural log, because our natural log is the same as a log with a base of e. So if I have the derivative of a natural log, that's a log with the base e of x, which is 1 over x times the natural log of e, which is just 1 over x times 1, or just 1 over x. That's how we see that there. Oops. Whoopsie. Not my intention. All right. Okay, let's keep going. Hopefully I don't accidentally click anything else. Yeah, so the derivative of our natural log is 1 over x, which will help us here. I see we've got more chain rule. So in this case, I see my outside is this first natural log. So u is going to be the natural log of v. And v is going to be all of this inside, but I see there's more inside, so it's going to be 4 times the natural log of that inside. I'll call it c, and c is 6 times t. Awesome. Our derivative of u is going to be, well, 1 over x and 1 over v. It's going to be v times the derivative of our inside, so I'll put that on top over v, right? Because the natural log of v is going to be 1 over v, but because it's chain rule, we also multiply by the derivative of our inside, which in this case is v. So it looks like that right now. And the derivative of our inside is going to be 4 times the derivative of our inside, and then over our inside, again, because the natural log of the derivative of natural log is just 1 over whatever it is. And then our c prime is just 6. Okay. So let's see here. If I plug that back in, that's going to be 4 times 6, which is 24, over c is 6t. And I'm going to simplify that. I see that 6 cancels out, so it becomes just 4 over t. Okay. And I plug that in up here, so it's going to be 4 over t over my v value, which is 4 natural log of 6t. And I see those 4's cancel out, so I've just got 1 over t over the natural log of 6t. And that's not at all in the form that they want us to get it in, is it? So I see that this is on the bottom and they want it to not be. So I know that what that means is I'm going to have 1 over t times this bit to the negative first power. So natural log of 6t to the negative first, because that's the same thing as just this, right? Because of how our exponents work. And then since I've also got this 1 over t, and they also want the t to be up there, I know that that's going to be a t to the negative first power times that natural log of 6t to the negative first. And we've just about done it, except I see that they're in the opposite order there, so I'm just going to move those around, which I can do, again, because we're just multiplying. And there. Now that's in the form we want it to be. We see that our a happens to just be 1 in this case because our other coefficients have canceled out. And then our power of b is -1, and the power of c is also -1. Now for number 10. Oops. Is that just from me writing that earlier? Where did that come from? All right. So now for this one, we need to use the quotient rule because we've got a quotient that has x in the top and the bottom. And wowza, it's going to get into some fun terms, but I'm sure it'll work out. So we've got this 2 plus 5 to the power of x over 3x. And I'm just going to put that in the box so we don't lose it. And remember that our quotient rule tells us we've got the bottom term times the derivative of the top, so low d high, minus our higher term times the derivative of the lower term, high d low, over low low. So whatever this bottom term is, squared, times itself. So I'm going to rewrite that. That's our bottom term, 3x, times the derivative of our top. And like I said before, the derivative of a to the power of x is going to be a to the power of x times the natural log of a. So I know the derivative of constant is 0, so it's just going to be 5x times the natural log of 5. Okay. And then that's this first bit, so then minus high, our higher term, so 2 plus 5 to the x, d low, so times the derivative of our lower term, which is just 3, all over low low, so it's going to be 3x times 3x, which will just be 9x squared. I'll go ahead and write it like that. And then we just want to simplify. So let's see. I see that I've got a 3 in both terms. I'm going to go ahead and pull that out. It's going to be 3 times, now it's going to be just x times 5 to the x times the natural log of 5 minus 2 plus 5 to the x. Or I suppose I could just distribute that negative, so minus 2 minus 5 to the x all over 9x squared. And I say I can cancel that 3 out, and my 9 becomes a 3. Obviously not a critical step, but it's still nice to simplify. Just get a little bit less going on. And then that is our answer, I believe. But yeah, pretty close. Pretty close to exactly how it's written down there. I'm going to just go ahead and move, oops. Okay, just going to go ahead and move that down there so we can see it. And let's double check. I've got an x times, times a 5x times a natural log of 5 minus, oh yeah, the 2 plus 5x all over, okay. So we've got x times 5 to the x times natural log of a, and our a is a 5, right? Minus 2 plus 5 to the x over b, which is 3 times x to the c, which is 2. And now for our very last question. If g of x equals this right here, we want to figure out the derivative of g of x. So this is once again chain rule. So I'm going to say u equals v to the negative third power, where my v equals 6 over x plus 6x. The fun thing about this is, although this is technically a quotient, we don't use quotient rule for this, because I can write this the same as, so if I've got 6 over x, that's the same as 6 times 1 over x, or just 6 times x to the negative first power. And that's really how we want to work with this, is with that power rule there. So it's just a coefficient in front. So let's see, derivative of our u, we use our power rule, so it's going to be negative 3v. And now this is where people get tripped up a lot. We subtract 1, and since this is a negative, negative 3 minus 1, it's going to be negative 4, right? So it's going to be negative 3v to the negative 4th times, now the derivative of our inside, which is v. So then we take the derivative of our inside. Well, if this first term is this right here, I know that using my power rule, it's going to be a negative 1 times a 6, so it's going to be a negative 6, times x, and I subtract 1 to the negative 2. I'm actually just going to rewrite that as a fraction, so I know it's a negative 6 over x squared. So negative 6 over x squared, and then the derivative of 6x is just 6. So now all we have to do is plug that back in. Oops. It's not working with me great. So the derivative of our u is going to be negative 3, 6 over x plus 6x to the negative 4th times negative 6 over x squared plus 6. And that's really all that is. We can leave it just like that. It is a little ugly, but that's okay. And I am, oh my goodness, why will it not select all of it? There we go. Now I'm just going to move that right in there. Just like that. Yeah. And that is it. All right. That was our last question, I believe. So this video is all done. This was based on homework number 8, in case anyone's forgotten. And I know it was a lot of chain rule. It was mostly just a lot of chain rule. But I hope that this was helpful. Remember that if you're stuck on any of the trig derivatives, or any of the derivative rules that we've worked on in this already, A lot of it is just memorization, unfortunately, but I do have a video up just kind of going through those in case you forget them or are struggling with them. But then again, also Google is very much your friend, as is Khan Academy, and I hope that this video helped. Thank you for watching.